All right, Jeanette, are you ready?
Yep.
Okay, welcome everyone. This is Spore's introduction to 3D printing webinar. It's the final 3D printing class of this year, and so Spore is basically an acronym standing for Support Public Outreach, Resources, and Education. And our parent NGO is Mycelium, and Spore is an outreach program dedicated to education efforts by Mycelium. And Mycelium's goal is to create a network of knowledge for self-sustainability and accelerating the circular economy. So we can go to the next slide. And what is a circular economy? So a linear economy is one in which we take resources, make products, and dispose. So it's just a linear train in which products are wasted after extracting resources. But a circular economy is one in which we take resources, make products, use, and recycle. So you might know of the four R's: reduce, reuse, and recycle. And then a circular economy has the recover aspect, where everything's in a cycle, so it reduces resource consumption and it's more sustainable in the long run. So my name is Ankur Shah. I'm the Director of Operations of Mycelium NGO, and we have with us on the call Dan Meisner, who is the Executive Director, and Jeanette Blasius, who's going to teach this class. She has a decade of experience in 3D printing. She's an amazing 3D designer as well, and we're very grateful to have her teaching this class for you. So with that, let's have Jeanette on the call. Thank you, Jeanette.
So here's a slide also where we've done some projects locally for Huntsville. We used to teach classes in person, but we moved to an online format. And when we had a 3D printing expo, and then we've made the recycling hub at UH, and just a couple of our projects that I had added here. Uh, but yeah, with that, we can get started with our class. So today we're going to be going over these topics. What is 3D printing? What types of 3D printers there are, how to get started, setting up a 3D model, and then finally, when you have everything ready, we can start printing. So first, we're going to talk about what is a 3D model, or what is a 3D printer? And basically you're taking a digital file and turning it into a physical object, as shown here. So basically you're getting rid of an entire warehouse of parts and turning them into a file server and one or many printers. So this is an idea to reduce spaces used by warehouses and such, and parts that aren't needed won't be made. So there's no waste of space there. Here's some other examples of uses. I'm pretty big into like cosplay and miniatures and stuff, so I've got a variety of different kinds of things. I've got for this year, I helped with a few initiatives to help spread uh, PPE for healthcare workers. I made these face shield bands, and then I've got some cosplay pieces here, and a couple of just some models and replacement parts around the house. Something breaks, you can just replace it with 3D printing. And then also there are some filaments that are food safe, so you can make cookie cutters or certain cutting material, cutting equipment and stuff like that. And then also, of course, what goes hand in hand with 3D printing is robotics. And I've got this video that I'm going to play for you. And this is a robot that our co-founder Dan Meiser built, and he can talk a little bit about it.
Yeah, so I built this robot mostly out of 3D printed parts and then just a couple of motors and an Arduino. And so this was kind of one of the examples of an R&D project we do at Mycelium, which are not only kind of fun and cool looking, but also have the potential to have major impact. In this case, the next step would be to add some kind of a 3D printing pen to this robot so it can walk around and 3D print things. And so that has some interesting applications in the future. So again, that's one project. There are other projects we do related to 3D printing, which we can talk about a little bit later in this. But like throwing 3D printing technology on a garden, and you can use it to actually robotically grow food. So, but again, and we'll talk about that in a little bit, but there are a lot of interesting projects we do, and this is kind of one example of one of them using 3D printing.
That's right. Cool. So this month's topic, we're going to talk about gift giving with 3D printing. So we've got the holidays coming up, and the one really cool advantage that I've had with 3D printing is I don't really have to buy much for most of my friends. Most of my friends are pretty nerdy, so we're pretty cool into. Uh, I gave out a ton of Baby Yodas last year, since it had just come out and they hadn't gotten the toys to the store yet. It was really cool to give those to my friends that hadn't been able to buy any toys from that. And then a friend of mine's dog, I just found a model on the internet and I painted it to look like their dog. And then this entire box here, this box with the moon on it and the D20, it's entirely 3D printed. It's actually pretty large. I thought that was a really cool project to print that and put it together. And then you can do all kinds of stuff with 3D printing and lighting. This just has a T. This box here on the bottom right has just a tea light inside. So it's just an example to show that you can really make something that you can't find anywhere. You know, just putting a little bit of effort, making it, painting it, and making something really special for someone. And then on top of that, you don't have to spend money. You know, these probably would have cost, at least 10 or so dollars to buy, and instead it took me maybe a couple of dollars in material and paints. So and then also if you're sorry about that. Yeah, I full screen. So this is some tips on buying a 3D printer for someone. Typically, there's some that are really low in price. I would recommend if you're going to buy someone a printer I would stick to at least one that's about $200 if that's the case. If you're buying something for like a grandkid or, someone really close to you. I have seen some people buy. There's one called the Wanhao Mini. I bought one for about $100, and it was okay for what it was, but it had a lot of issues. So I feel like if you're gonna buy someone something, buy them one that's not going to break like mine did. Also, there's printers like this one here that this I know one of them is a Da Vinci brand. I'm not absolutely sure if this one here is the same, but there are some printers that will require you to buy their filament, which the filament is the quote unquote ink that the printers use, and that while the printer will be really cheap, you'll have to buy their filament. The person you buy it for will have to buy their filament, and they typically are quite a bit more expensive for the filament than you normally can get it for. Our recommended printers are, and we'll touch base on this a little bit later in the course, but the Creality Ender 3 is the hottest printer right now. Everyone that is buying a printer has been buying this Ender 3. And they're usually about $300 or $200. You might be able to get a refurbished one for a little bit cheaper. And then filament is typically about $20 to $30, depending on the type of filament that you get. I don't recommend getting it from like Staples. Try to buy either direct or on Amazon. They typically keep their prices pretty low and have good quality. So there's actually many types of 3D printers. I'm going to talk about three different types. The main one being the FFF or the FDM printer. This is the standard home printer. It uses a plastic string called filament that prints it squeezes out this molten plastic using these gears and a hot end, and it squeezes out this plastic into a pattern, raises a little bit, squeezes out a pattern, raises, squeezes out a pattern until you have your model on the bed. And then a little bit about the filament that you can use. There are several different types. The common type is the PLA, which is a biodegradable filament. It has a pretty low melting temperature, so you have to be careful leaving this once you're done with your model, leaving it in the car or something like that, but it is very easy to print with. It's also non-toxic, so you can make some food products, food making equipment out of it. The next popular one is ABS, which is a toxic material, but it is very strong. I think this is usually the go-to that people use for cosplay and stuff because it doesn't. It's stronger. You can smooth it out with acetone fumes, and so cosplayers like it because it's easy to work with as far as the after making the model. But printing in it is a little bit harder. Whereas the PET is it's about as hard to work with as ABS. It's a little bit finicky with temperatures as ABS is. However, it is non-toxic. It's actually even more safe for the environment than PLA is in a way. It's typically asked for when I was doing the making PPE for medical workers. They were asking us to use PETG. This is also the same plastic that plastic bottles are made out of. So there are a lot of we made a project where you put in a plastic bottle and you get 3D filament out. And a lot of places are trying to do stuff like that. You also have some options for some other types of materials. You have nylon, which is it has a little bit of a give to it. You have carbon fiber, which is a really strong material, and then you have TPU, which is a rubbery material. It's kind of fun to work with because you think of 3D prints, you think of them as really rigid pieces, and then you have TPU that is just like basically rubber once it's finished printing. And then you can get stuff like composite, which is metal infused or wood infused or something like that. I've seen one. It's really cool. It has iron filings in it. So when you're done printing it, you can spray water on it and it will literally rust. So you can make something really cool looking if you're making a cosplay piece that's for steampunk or something that just has to have that nice rust finish to it. So the next kind of printer is the SLA printer, which is a resin-based material. So it basically you have this vat of liquid and a laser or a display that will display the light in a certain pattern, and then the bed actually goes in the other direction. So it just displays it on the bed, and then it raises a little, and then it displays it on the bed, and then raises a little until you have a shape. And you can get some incredible detail with this. It looks like something from sci-fi. So here's a quick clip of one of these printers in action. It says sped up, but it is faster than the FDM printer by a considerable amount. So it just pulls it. Basically looks like it's pulling it out of this liquid. It's really fun to watch. So I actually just recently purchased a very small one of these printers. So here's a few pieces that I did. I didn't realize when I got this printer, it does take quite a bit of work on the after you're done printing. Well, before you print and after you print, it takes a little bit more work than the FDM. So it comes out of the vat as this like almost like gelatin looking models, and then you have to kind of clean it. It You have to make sure you have all the supports gone, and then you set it out in the sun or you put it under a UV lamp and it will cure into this very hard material. And you can sand it or whatever you need to afterward. But it's really small printer. It's only about 3" by 5", but it has been excellent for making miniatures and stuff. And I'll talk a little bit more about that later. The next printer is a powder printer. So this printer is good for machine parts and other things like this. So the way this one works is you have this vat of powder and a piston kind of raising it and putting it into the other container, and then you have your bed here. And so your bed is all the way at the top, and it puts a layer of powder, and then this laser will sear the top in a pattern, and then it lowers just a little bit, and then it sears the top in a pattern, and then it lowers a little bit, and it sears a pattern, and then lowers it. And so then once it's done, you have your part. And I have a little video of it showing how it's making a machine part. Looks like some kind of flywheel or something for a machine. Just sears it, and then it puts a layer of powder. This is probably an aluminum or something. It There's also another kind of powder printer that's become popular lately. One of our guests in another class asked about this one time, and we actually have a company in Huntsville here that does this sort of thing. So um, I'm not sure what the material is on these, but they have this. I believe it's like a nylon powder or something, typically, and it prints it just like the powder, except then it goes over it with a layer of ink. So it's sometimes they're called inkjet 3D printers. So they print and then they inkjet print over it with ink until you have this personalized um, model. I've seen them at Dragon Con or other conventions where they have um, these booths in the vendor booths in the vendor hall. They'll have these people with a booth that they have this like kind of giant lazy Susan that you go and stand on, and they'll scan you, and then you come back in a couple hours and you have an action figure of you in your cosplay or something. And I always thought those were really really cool. And then here on the bottom right is a photo from Clemson University. They had just recently purchased a printer for making mock-ups of packaging. And so this bottle that you see here is entirely 3D printed out of powder. And it's just, I think that's incredible. It has that much detail. We've gone this far with 3D printing. And where is it going to be in 10 more years? So as mentioned before, these are the 3D printers that we would recommend um, normally for purchasing for yourself or for someone. We have the Creality Ender 3, which is the popular one right now. It's very easy to use. It's a really nice printer. And I've got this next one, the Creality CR10S. It's a little bit bigger model to it. I bought it a year and a half, maybe 2 years ago, and it has been a workhorse. It's a cubic foot printer. I bought mine for about 350, whereas the smaller one's about 200. I bought mine 350, but however, that was refurbished. So I think new, the CR10 is typically 400, 550 if you want the newest model. I think they have a higher end one that's about 7 or 800. And then the SLA printer that I mentioned earlier is this longer orange 10. That's the miniatures 3D printer that I purchased just a few, like I think it was earlier this year I purchased this printer. And it's been cool so far. I've seen some reviews saying that it has some limitations, but for me, just making miniatures, it's been pretty awesome. So I recommend this. This one was about 120, I think, brand new from the company. It did not come with the resin. I had to buy the resin separately. The resin is typically about 30 to 35, depending on how many. They come in about a half liter to a liter. So you can usually buy a liter for about 30 to 35. And then if you want a really high-end printer, we recommend the Prusa models. The Prusa printers have come a long, long way, and they're incredible printers. This is one that we donated to the local library here. We raised money and donated one to the one of the branches, and we never have to come and fix it. It always just runs and runs and runs, and that printer runs constantly. Featured here is actually one that is a dual filament printer. So you can actually print FDM in color, sort of. You can have two filaments loaded at the same time. And if the model is calibrated for it, you can have it print in two different colors. So that's pretty cool. So now that you know about printers, let's figure out how to set up your print. So first we're going to show how to get a file, and then how to prepare it, and then print it. So if you don't really know much about 3D modeling, there's plenty of websites where you can find lots of models depending on what you're looking for. The first place I always look is Thingiverse. It's kind of the go-to for most people, I think. It has everything is free. They have a pretty good interface that shows comments or likes. They have remixes. They have all kinds of stuff that you can even have a viewer. There's a viewer inside the browser that you can actually kind of move the model and kind of look at it. So Thingiverse is our first recommendation. Then second, I really like to try and find stuff on My Mini Factory. They have some really high end, especially SLA prints, stuff for miniatures and things like that. However, they do have some models that are charged for, and they have a little bit of limitations on what kind of prints they have. They actually test everything that comes through their server. So while it won't have as much as Thingiverse, you know that everything that you download from My Mini Factory is going to be a certified good print. Then there's a few other places you can find places if you can't find pieces on the other two places. Yegi is kind of like the Google for it. It'll look everywhere. You'll get pay sites, you'll get all kinds of stuff. So if you're really looking for something obscure, I recommend checking Yegi. And then I've done this. I've gone to Google Earth and pulled models from Google Earth. There's a building in Huntsville that a friend of mine really likes. So I just pulled it from Google Earth, fixed it up and printed it out and gave it to them. Little piece of home for them. And then also there's Sketchfab. You can find some stuff. It's more of an art website, but if you can't find it anywhere else, you can try there. Or you can take the other option of making it yourself. There are two different kinds of 3D modeling. There's CAD modeling, and then there's 3D modeling, actual modeling. CAD is for really precise pieces. If you're making a part for the house, I recommend just trying CAD first. It's a lot easier to do in that, I think. The modeling software that I use is more like modeling clay. So it's you can still get precise pieces, but I think it's a little bit easier to do in CAD. So we actually did a class on this recently, and you can actually find our recorded lesson on this. It is a program that our co-founder has helped develop, and he's also a member of a co-founder of this organization as well. It is a browser-based CAD software called 3dorchard.com, and you can basically make the model in the site. You can see what other people have made. You can remix it. It has this really cool feature where if you remix it, it kind of makes a branch of a tree and goes this way. And then if someone wants to remix the original, the branch of tree goes this way, and then it can split from there. Really cool visual, and then you can always go through the history of a piece. So if you want to try your hand at CAD, I recommend this site. There are a few other sites that you can do CAD, like Tinkercad. You can put shapes together, but I think 3D Orchard is a lot more powerful tool than some of the others out there. Then there's also a modeling software that I like to use that is free to use as well, and this is Blender 3D, and this site is this software has gone a long way. It has all kinds of functionality, but it is complex. I have tried learning this program, and I'm able to do the basics, but it has game design, it has video editing, it has all kinds of stuff built in that I haven't even scratched the surface on this program. Like you can see this image here is from a video that someone had made. So one of the cool things I like about Blender is every year they hold a film festival that they push the limits of one certain thing. So like one year they did hair, and they had a bunch of people make videos about hair physics, hair color, all kinds of stuff. And then they did the film festival, they gave awards, and then the next year they picked something else with the program a little bit more fine-tuned for hair. And then they did that, and then the next year they did water physics, and they improved water physics. And so the program has just improved along, centered around this film festival. And I think that's a really cool thing that they've done. And you can use it too. Anyone can use this program. And there's a Ubisoft has used this for some of their game development for Assassin's Creed and stuff. So you always hear about Maya and stuff, and I could never afford anything like that. Now I've got a program that I can use just like the professionals. I recommend checking it out. So once you've got your model or you've made your model, you have to set it up for the printer. So basically you take your model and you give it in the kind of format that the printer wants, which is layers of pattern, or like we like to say, pancakes, and it prints it out in these patterns until you have your model. So this software used is called a slicing program. The most popular one is Multimaker Cura. I think most beginners use Cura. It has all the functions that you need. I also recommend Autodesk Mesh Mixer. It has a better, I think it has a better system for building supports, which I'll explain later, but it has these little tree supports that it uses instead of the blocks that other software uses. And then there's also Simplify 3D. It is a paid service, but everyone that I know has purchased this program. I believe it's about 175. Have enjoyed using it. Said that it was worth every dollar. So I would check that out if you're serious about getting into 3D printing. And then the last one I'm just going to touch a little bit is Slicer, which is a G code editing software. So you can do slicing, but you can also do much more. You can tell the printer specific coordinates to go to, certain functions that the other programs I think might be able to do it, but not as easily as Slicer can. I only recommend that for higher end users, as messing with the G code could have some complications. So as said before, you're going to take your digital file, turn it into the format it needs, and turn it into a physical object. And to do that, you put your model in the software, and you can move it, you can resize it, you can rotate it, mirror it, all these different things, and until you have your print exactly how you want on this virtual bed here, you can go to the next step where you set up exactly how it's going to print as far as the density and such. So when you're printing a print, you're not going to want to print it solid, or it's going to take a long time. So the way a print is set up is you have your top and your bottom layers, and then you have your shell and your infill. So the standard for Cura is 20%, and that's a pretty good fill. Like, that's really strong. I typically go lower. I do mine at 7%, but I thicken my walls a little bit. Since I do miniatures and cosplay pieces, it's usually good enough. But if you want to have something that's going to be load bearing or something like that, you're going to want to go a little bit stronger. Maybe not quite 50%, but if you just got to have the strength in there, you can try that and see if you're willing to wait as long as it's going to take to print that. So another parameter you have to edit is your quality level or your layer height. And what this is going to do is there's actually a distance between the layers of pattern that it prints. And the more layers, the more quality you're going to have. However, it's going to take a lot longer. So I have an example here where I took the same model and I put it at different layer heights. So you can see here at the very fine, it's going to take about 7 hours. It's going to take this much material. It's about the same amount of material, but it's going to take a long time, but it's going to look fantastic. Then you've got your next layer height, which is the 0.2, which is your normal. I think this is called standard in Cura, and I think most people print at 0.2 layer height, because this is only going to take an hour and a half. That's a pretty normal amount of time to wait for a small print. And then if you're really just got to have it soon, or you don't care that it's going to be a little bit fragile or a little bit rougher on the edges, you can go 0.3 and save a little bit more time. Any less than that, I would not recommend, because then you risk what's called delamination, where your layers are actually going to come apart when you pull the piece off. So be careful of how loose you want them. So here's the basic menu that you see in Cura. You can see the layer height versus print speed. You can change the infill. You can generate support if it's going to need supports. And then you can check build plate adhesion, which build plate adhesion is the extra material that's going to print around your print. You can either have it print none at all. You can actually have it not print this. This teal area is what the plate adhesion is, but you can have it not print this at all, or you can have what's called a skirt, which I like to do this. It basically puts a thin line around your entire build area, and it shows that the laydown of the filament is going to be doing fine. So once that prints, you know that everything inside of it's going to print too. And then this is good for this next one. The brim is good for if you're going to have a tall piece. I recommend doing a brim. It just prints a really thin layer, several lines around it to kind of anchor it to the bed. So if you've got a tall piece, it keeps it from wobbling or falling off, which would be really bad. Then there's also a raft, which is a lot. It's just like a brim, except it prints an entire pillow of filament beneath it and around it. And it is it adds a lot of time, it adds a lot of material, and it really is just recommended when to use this when you're having some bed adhesion problems, some bed leveling, like some weird low spots. So you can keep that in mind when you're setting up your print. All right, supports. Supports are very, very important. So when you're setting up a print with FDM and SLA prints, you have to keep in mind parts of your piece that are sticking out. So like this T was sticking out. They didn't use supports. And so when the filament got to that point, it didn't know what to do. It just kind of squirted in the air and started a spaghetti mess here. And you can actually turn on automatically in the slicing program these supports, and these supports are what you see in Cura. They're just these blocks of filament that they put in a zigzag. It's actually a zigzag pattern, but it's a lot of filament, and it leaves kind of a rough spot, but it keeps your print from looking like this and completely ruining your part. The best thing to do is to try and engineer your piece to be like the Y, where it prints at a 45-degree angle, so you don't need supports. You don't have to worry about having a spaghetti mess. It's already built into the file and it's good to go. So that's another model to look for is no supports. So there's some really, really neat models that people have come up with, having people in certain poses so that it doesn't require supports to print it. And then once you've got your model good to go, you've gotten all your settings where you want it. I recommend always checking the preview menu. So most slicing programs have this preview menu where you can actually slide up and down what your print is going to look like from start to finish. It'll actually look like it's virtually printing your print on the screen. So you can make sure if there aren't any holes, there aren't any parts not being held up with supports and stuff like that. Just weird areas. I always recommend checking this out before you hit print. So the next step is to save your file. I have a naming convention when I save my files. I put the number of hours and the printer, since I have multiple printers, I put the printer short for it, and then the name, and then the type of material. That way I know, okay, I've got to go to work in a few hours. I've got a couple hours. So I put this 6-hour print, and then this is definitely for this printer. This is what it is. This is the temperature that's set for. Different materials call for different temperatures. So you, if you're going to be working in multiple different materials, then it's good to have that listed in your part before you go print. So then we've got everything ready. We've got their file, we've got the model set up, and we can move on to printing. So here's a snapshot of my printer. This is the CR10S, and this basically you've got your filament spool on top of the control box, and the filament kind of comes through and it goes into the top extruder. This one has 2 extruders, so yeah, 2 extruders. So it goes in here, gets pulled by these gears. It goes kind of loop-de-loos over here into this tube, the PTFE tube. and it goes into the print head where the heat block is. And then there's another set of extruders that pull the filament there as well. So when you turn on your printer, the first thing you have to do is set or turn you start the heating element, and you tell it. On mine it asks what kind of filament are you running. So when I hit PLA, it heats it up to about 210 and heats up the bed about 60 degrees. And then the ABS, it goes considerably higher. It goes to 240, and it sets my bed to 100 degrees. But I usually say I use the ABS setting when I'm printing in PETG, and so I lower it just a little bit. But you can edit these temperatures in your file as well. So it'll preheat to that temperature, but once you load your file, it'll go back down to whatever temperature, up to whatever temperature. So the next step after your bed or your hot end and your bed have heated up is to level your bed. Most printers, they have a set of screws on the bottom where you set them. You kind of use a piece of paper to make sure it's close to the bed, not too close, but not too far away. So as soon as you can slide the piece of paper back and forth under it, your bed is level. On my printer, I purchased a auto leveling sensor, which is awesome. I heat it up, I let it get to temperature, and then I hit the auto level, and it kind of goes across the bed and pinpoints. And then once it's done, it's all ready to go. If your printer is capable of having one, I recommend it. It's about $50 for a kit to add this, but I think it's really awesome. And then also here's just a few tips and tricks that are common with 3D printers. Your printer will usually come with a set of tools like this. I recommend buying extra nozzles in case you have a failure and you don't want to wait for the part to come in. You just have them ready. They're pretty inexpensive. And then also the really cool thing about having a printer is being able to upgrade it with itself, like self replication. So once you get your printer, you can type in your printer's name into Thingiverse or somewhere, and you can find all kinds of upgrades. This picture here is showing a filament cleaner box, which is I just printed the box, and then I put a piece of foam inside, and it catches cat hair, it catches lint, it catches all kinds of stuff. So it's better to be in there than in my print head where it's going to get stuck and cause a jam later on. And then I recommend not running out of filament. It is a big pain in the butt when you run out of filament, and then on mine, it has the tube. So if it runs out, you'd have to take it apart to be able to get it out. So try to avoid running out of filament. Mine has a filament sensor, but it is more pain than it's useful. So I don't use it, but if you like using that, it helps if it works properly. Mine didn't work properly. So then I use this on just about every print. Is glue stick. You just apply a little glue stick to the glass bed that I use, and it does wonders keeping the prints stuck to the bed. So if you ever have any trouble having a piece stick to the bed, I recommend glue stick. Or if you're really having trouble, Aquanet does a great job, although it makes a mess all over the place. But I have a can of hairspray for those pieces that just really I'm having real trouble with. And that's everything. I hope you guys enjoyed it. If you have any questions, Ankur, we have any questions in the chat?
I think Dan answered them, but now is the time for Q&A. So if you have any questions, we encourage you to just talk to us. Show us your face if you want to, but you don't have
Yeah,
to.
you can unmute
But
and
unmute yourself and please ask us. And yeah, we look forward to interacting.
do we allow unmuting? I don't know if it
Yeah.
Anyone? Okay, I didn't know if it needed
anyone
to.
should be able to unmute. Yeah.
Okay. But yeah, we do these classes. We started doing the 3D printing intro every other month, and we do kind of an offset class on the other times, like some circular economy centered ones. And so if you wanna join us or want to know when we're doing a class, we have most social media: Facebook, Twitter, Instagram, LinkedIn, And then
Yep.
we just recently started a Discord channel. If you want to join us or just throw tips at us or just chit chat. Um,
Yeah, and we'll be sending up a follow-up email, so keep an eye out. We record these sessions, upload it to our YouTube channel, and then send the recording along with the presentation. So please do keep an eye out. Our we do these classes for free. Everything we do is right now completely free. So we just ask and we'll appreciate your support if you can join us on Facebook, Instagram, or Twitter.
mhm.
Our handles for all three are just Spore HSV. That's it. Just like the middle of this website, Spore HSV.
Yeah, you can find all our information there.
Mhm.
So if you want to talk about us or share with your friends,
Yeah, that would be awesome. But yeah, please, any questions, any comments, anything at all?
let's see. Talking about the bottles. Oop.
Okay, so Braden asks, what 3D printer do you recommend?
So I recommend my printer is awesome. Is it here? I think it's here. There was the slide about the printers. Well, I can go back to the one that I made for this particular class. Um, I have some pictures of it, but I recommend if you're just going to be getting it, if you're just getting started, I recommend the Ender 3 series. It Most people have been buying this one. I think it's actually a little bit, I think 200 is about right. I think it was 220 earlier this year. They were having trouble actually keeping these printers on the shelves. Everyone was buying them to try and help get PPE for uh, uh, healthcare workers. Uh, since it's pretty cheap, people were just buying two or three just so they could be able to print more and more stuff. But then if you're really serious about it, I recommend the CR10S. It is a wonderful printer, and it has helped me for 2 years and no issues. It just really depends on what level you're willing to go to. There are some higher end ones. I know people that are happy with uh the MakerBot. I think they're quite a bit more, but they're happy with that one. Stuff like that.
Hmm. Great. So it depends on where you're starting at and your
Yeah.
level.
Yeah, unless you're talking about, are you talking about SLA printing? I don't really have a lot of knowledge on SLA printing, but yeah.
Yeah. Sweet. Any other questions or anything at all?
Yes.
Feel free. I mean,
Yep.
very happy to answer any questions. Well, if not, please do visit our website. This is www.sporthsv.org. And again, we'll be sending out an email with the presentation you just saw, recording, and the links to follow us. So
Mhm.
thank you for joining. We hope you like this class and learned something. And thanks for taking your time
Yep.
on a Saturday. Oh, Stephen asks, which came first, spore or
it
mycelium?
was it was actually mycelium. Well, actually, let's see. The idea of teaching, actually we were teaching classes before with another group, and we started wanting to do more projects and outreach globally and stuff like that. So we kind of broke away from that group and we started Mycelium and Spore. Spore was the teaching part because we still wanted to teach classes. So they kind of were at the same time, but it was kind of Mycelium that drove the charge.
And in nature, that this is the play on words. In nature, mycelium is the network underneath the soil from which mushrooms sprout, and spore is kind of the seed of a mushroom. That's how mushrooms propagate. So,
Yeah.
uh,
So it was my yeah.
yeah.
Yeah, the idea was Mycelium was that we're a network of of knowledge.
Mhm.
So kind
Yep.
of went on that play on words.
Well, awesome. Yeah, please check us out. We will be adding you to the email list and sending an email. So thank you so much for joining again, and we really appreciate your time.
Yep. Thank you everyone.
Thank you all. Have a good day.
Yep. Bye.